Good day everyone. We will now be talking about RSA asymmetric encryption algorithm. RSA algorithm is asymmetric cryptography algorithm. Asymmetric actually means that it works on two different keys, public key and private key. As the name describes that the public key is given to everyone and private key is kept private. The idea of RSA is based on the fact that it is difficult to factorize a large integer. The public key consists of two numbers where one number is multiplication of two large prime numbers. And private key is also derived from the same two prime numbers. So if somebody can factorize the large number, the private key is compromised. Therefore encryption strength totally lies on the key size, and if we double or triple the key size, the strength of encryption increases exponentially. RSA keys can be typically 1024 or 2048 bits long, but experts believe that 1024-bit keys could be broken in the near future. But till now it seems to be an infeasible task. To begin, let us start generating a public key. These are the steps in generating a public key. First, you have to select two prime numbers and them assign as P and Q. Second, let n be equal to P times Q. Third, select a number to assign to E such that E is greater than 1 but less than phi of P and phi of Q. Also, it must not be a factor of n. Fourth, the greatest common divisor of E and phi of P and phi of Q must be 1. Finally, the structure of the public key is E, n. For example, first, I assign 7 in P and 13 in Q. Second, the product of 7 and 13 is 91, so n is equal to 91. Third, I chose 5 to assign to E since 5 is greater than 1 but less than and not a factor of 72. Fourth, their greatest common divisor is 1. So the public key is supposed to be 5,91. Now let's move on to generating the private key. And these are the steps. First, you must solve D where D is equal to the product of K times phi of P and phi of Q, plus 1, all over E, where K is equivalent to 2, and it is a constant. The structure of private key is D, n. After substituting the values and performing the operations, we come up with the number 29 as the value of D. With this, we can conclude that the private key is 2991. Now, let's move on to encryption. For example, I want to encrypt letter V in my message. Letter V is the 22nd letter of the alphabet. We should solve this equation stating C or the ciphertext is equivalent to L, letter of the alphabet and number raised to the power of E modulo n. So 22 raised to the power of 5 modulo 91 answers 29. So 29 is the ciphertext. It's now time to decrypt the text. In the decryption of the data, we have to follow this formula, where L is equal to C raised to the power of D modulo n, and then substitute the values and there it goes. The answer is 22. And the 22nd letter of the alphabet is V, the secret text. RSA is one of the first practical public key crypto systems and is widely used for secure data transmission. In such a crypto system, the encryption key is public and differs from the decryption key which is kept secret. A public encryption method that relies on a public encryption algorithm, a public decryption algorithm, and a public encryption key. Using the public key and encryption algorithm, anyone can encrypt a message. The decryption key is known only to authorized parties.